Hello everyone, this is Sir Amir Khan, and today we are continuing electrostatics. Today we will deal with potential energy due to a system of charges, which will include potential energy due to a system of 2-point charges, due to system of 3-point charges, potential energy of charges in external field, which will include system of 2-point charges in external field and potential energy of electric dipole in external electric field. So without wasting any time, let us start with the first point, which is potential energy due to a system of 2-point charges. So as you can see from this diagram, I am having a 3-dimensional coordinate system here, in which point A and point B, which are having charges q1 and q2, are at distances r1 vector and r2 vector from origin. Distance between AB is given by r2 vector minus r1 vector. So work done in bringing q2 from infinity to point B. Just consider, when there is no field here, my first charge comes here, no work is done in bringing it because it is not experiencing any force. But as soon as the second charge comes, this first one will apply some force on it, and so it will have to do some work. We will have to do some work on it to make it come here. So this is the work done we are going to find out. The work done in bringing q2 from infinity to point B near charge q1 is given by work equals to potential of second into charge of second, where V2 is the potential at B due to q1. So how do we find V2? We find V2 as V2 equals 1 upon 4 pi epsilon naught q1 upon distance between A and B, AB, or it is equal to 1 upon 4 pi epsilon naught q1 upon mod of r2 vector minus r1 vector. If I put equation number 1, so our work done becomes 1 upon 4 pi epsilon naught q1 q2 upon mod of r2 vector minus r1 vector, and this work done is stored in the form of potential energy. Therefore potential energy becomes 1 upon 4 pi epsilon naught q1 q2 upon mod of r2 vector minus r1 vector. Also, if you remember, mod of r2 vector minus r1 vector is equal to r12, which becomes u equals to 1 upon 4 pi epsilon naught q1 q2 upon r12. So we find that the potential energy due to a system of two charges is given by u equals to 1 upon 4 pi epsilon naught q1 q2 upon r12. Next up we have due to a system of 3-point charges. Now we are considering that we are having A, B and C at distances r1 vector, r2 vector and r3 vector from an origin. Charge at A is q1, at B is q2 and at C is q3. So now what will happen? When A comes, no work is done on it. When B comes, A experiences force, so work done on B from A. When C comes, then A and B both experience force, both exert force on C, so on C the work is done by A also and by B also. Distance between AB is given by r2 vector minus r1 vector. Distance between BC is given by r3 vector minus r2 vector, and between AC is given by r3 vector minus r1 vector. So total work done is equal to work done by first on second plus work done on first by first on third plus work done by second on third. Now work done by first on second 1 upon 4 pi epsilon naught q1 q2 upon mod of r2 vector minus r1 vector, which we have found by directly using this formula, not this one but this one, by directly using this formula. Work done by first on third 1 upon 4 pi epsilon naught q1 q3 upon mod of r3 vector minus r1 vector, just replacing 2 by 3. By second on third 1 upon 4 pi epsilon naught q2 q3 upon r3 vector minus r2 vectors mod. We replace r1 vector from here with 2 because here it is 2 and here it was 1. So the total work done, just add all these. So 1 upon 4 pi epsilon naught is common and I took out it common, into q1 q2 upon mod of r2 vector minus r1 vector plus q1 q3 upon mod of r3 vector minus r1 vector plus q2 q3 upon mod of r3 vector minus r2 vector. Now this total work done is stored as potential energy. Therefore potential energy equals 1 upon 4 pi epsilon naught into q1 q2 upon mod of r2 vector minus r1 vector plus q1 q3 upon mod of r3 vector minus r1 vector plus q2 q3 upon mod of r3 vector minus r2 vector. Now if I have to convert it into summation, there is a problem. The problem is that here we have q1, here we have q1, but here there is no q1. Here we have q2, here we have q2, but here there is no q2, and here there is q3, here there is q3, but here there is no q3. So it is very tough to add. So what we do, we think of it as a problem having these three, and I have it as a double in summation. With double summation, what I am doing, I am having I equals to 1 from 1 to 3 and j equals from 1 to 3, but I is not equal to j. But when I am doing summation once, it is getting equal to this. When I do it twice, it becomes twice of this value. Now just think, I am adding something once, the exact value I will get. But if I am adding it twice, I will get the value as twice of it. So I add it twice and multiply it by half. So what I was getting was twice the value, and when I multiply it by half, I get the exact same value which I should have got. And if there are n charges, like for 3 charges I found out, for 2 charges I found out, if there are more than 3 charges, then what we do, we use the formula potential energy equals half 1 upon 4 pi epsilon naught summation of I equals 1 to n, summation of j equals 1 to n, where I is not equals to j, qi qj upon mod of rj vector minus ri vector. Now moving on to potential energy of charges in external field. The first one is system of 2 charges in external field. So I am having point A and point B at distance r1 vector and r2 vector from origin, but now origin is having a charge q and A is having charge q1, B is having charge q2. Distance between AB is r2 vector minus r1 vector. So A and B both are in the external field of O. So work done in bringing A will be given by the work done on A due to O, and work done on bringing charge Q2 at B will be given by work done by O on B as well as by work done on A by A on B. So the first work done is equal to Q1 into V R1. This is Q into V work. But work done bringing Q2 from infinity to B, W2 equals Q2 into V R2. This is against this O. Okay. If R12 is distance between Q1 and Q2, there is the distance. Then work on Q2 due to Q1, work on Q2 due to Q1. Work 2 equals 1 upon 4 pi epsilon naught Q1 Q2 upon R12. Correct. So using principle of superposition, I just add all these. So we have work done equals Q1 VR1 plus Q2 VR2 plus 1 upon 4 pi epsilon naught Q1 Q2 upon R12. Now we know that the total work done is stored as potential energy. So U becomes Q1 VR1 plus Q2 VR2 plus 1 upon 4 pi epsilon naught Q1 Q2 upon R12. Next up we have potential energy of electric dipole in external field. I am considering that this is my electric field, and a dipole, this is my dipole, which is placed inside the electric field. Basically I can think that the dipole was first placed in this direction and the electric field made it turn, because one of the ends of dipole, which is positive, will experience the force in the direction of electric field. The other one, which is negative, will experience the force in the opposite direction. So equal and opposite forces separated by some distance become a couple, and when there is couple, there is rotational motion and there is torque. So if I have to find torque, the magnitude of torque acting on dipole is equal to Pe sin theta, which we have studied earlier also. So magnitude of torque acting on dipole, tau equals to Pe sin theta, and the small work done in turning the dipole through an angle d theta, like here it is theta, but I am just considering it moved by a small amount, not necessarily by this amount. Like suppose it was earlier at this position and now it is at this position, so this angle I can take d theta. Okay. So the small work done in moving it by an angle d theta is dw equals tau d theta, or it becomes Pe sin theta d theta. If I have to find a total work in moving it from 90 degree, this is 90 degree, to this angle theta, what we do? We take work done equals to integration of dw from 90 to theta, which is equal to integration of Pe sin theta d theta from 90 to theta. So work done becomes Pe, which is constant, comes out, integration of sin theta d theta from 90 to theta, or the integral we know of sin theta is minus cos theta, so it becomes Pe into minus cos theta into from limit is from 90 degree to theta. So work done becomes minus Pe, taking this minus out, minus Pe cos theta upper limit minus cos 90 degree lower limit. Cos 90 is 0, so what do we get? Work done equals to minus Pe cos theta, and this total work done is stored as potential energy, and therefore U equals minus Pe cos theta. So this will be all for today. In the next video, we will start from capacitance. In the previous video also I said that we will start from capacitance, but then I forgot that these topics were left. In the next video, we will start from capacitance. If you have liked this video, please subscribe to my channel, share it to others and like the video. Thank you and have a nice day ahead.